Welcome to Talkin Tires, the podcast that delves deep into the world of tires. Join us as we explore everything from the science behind the manufacturing to the latest innovations in tire recycling. Our aim is to provide you with a comprehensive understanding of tires, including how they work, how to maintain them, and how to dispose of them responsibly. Whether you're a seasoned mechanic, curious car enthusiast, or an avid recycler, Talkin Tires is the perfect podcast for anyone who wants to learn about the essential component of the modern vehicle and heavy equipment. So buckle up and join us for an informative and engaging journey into the world of tires.
All right, welcome to another podcast, Talkin Tires. I'm your host, Craig Hunter, the president of Tire Reclaim, and I have here with me Jonathan Selbie of Univrses. Now, this is a very interesting podcast, and in the introduction, you've heard that this podcast is about everything that has to do with tires. So everything from recycling tires to the manufacturing to, well, in this case, digital security, safety, and the performance of cameras communicating about tires. And I'm going to let Jonathan go into all about that and road safety and potholes. And we're going to go down this rabbit hole that we've got here. But I want to get started by just saying welcome, Jonathan. And I guess it would be good evening to you.
Actually, I'm in California at the moment, so I'm not too far away. So it's
okay.
We're on the same time zone at least.
Yeah, your counterparts had said, "Oh, so this is going to be at 8 p.m." and I'm like, "Oh, and you must be in the United Kingdom." Okay, you're in California, so no, then good afternoon. I'm catching you on your lunch break.
Exactly. Good afternoon. Nice to be here. Many thanks for having me, Craig.
So you've had an interesting path getting to where you are now: Formula One engineering, aerospace, autonomy. I'm looking at my notes here, leading into AI company focused on roads. So why don't you tell us a little bit your story? How did you get started, Jonathan? And maybe tie this all together with tires and Talkin Tires. And
Sure, I'll give it a go. I mean, look, I originally did quite a technical degree at university, and I wanted to work in a field that was used that expertise I'd gained, but had some excitement. I didn't want to go down a particular field, and so I decided to look into motorsports. Managed to score a job at Formula One, working for the Red Bull Racing Formula One team. My role there was an R&D engineer, so I was more or less tasked with two high-level objectives: either make the car go faster or make it more efficient, so burn less fuel to do the same job. And so we worked on things like aerodynamics, we worked on gearbox enhancements, we worked on control systems. One of the particular things was about the launch control. When the lights go from red to green and the car has to accelerate at maximum speed. Of course, that's when you're looking to understand the available traction from the tires. And so there was a lot of work we did trying to understand the temperature of the tires, how to get them quite quickly on the warm-up laps to the optimum temperature, to the optimum performance window, so that when you arrive and have that uncertain delay, before the lights go from red to green, you've got that optimum traction available, so you can apply the correct torque to the axle and to accelerate as fast as possible past all your rivals. So I did a lot of work in those domains and really enjoyed it, but found myself working in motorsport. It's quite a focused field. It's very very particular challenges associated with it, and I wanted to broaden the domain a little bit. So I took myself off and I did an MBA, tried to get a bit more business experience, and then helped found a drone company using small-scale surveillance drones, selling systems to the UK MOD, to the US DOD, focused on trying to understand situational awareness for troops on the battlefields and in other applications as well.
Wow, I had no idea.
Yeah, and then so that was a good times, and then actually moved to Sweden, to Stockholm, where I helped to develop this company Univrses that you talked about, where the core competence in the company is actually nothing to do with tires; it's to do with cameras, and so this is where you use cameras to give mobile platforms, perhaps robots, perception. Cameras become the eyes, if you like, of the autonomous system. And so this was building on work that I'd done with the surveillance drones, where you use cameras a lot to help the drones navigate and understand the world around them. But now we focus in two areas. Automotive. So we work with some leading OEM brands. We use the cameras to give the cars ADAS and AD functionality, to give them perception so that they can drive themselves, they can be more safe in the environment. But also, we work in the road management environment. Our belief is that these cars are equipped with all sorts of sensors that not only help them drive themselves, but will give information about the road environment that can be leveraged by the DOTs, the Department of Transport, at the state level, but at the national level as well, helping them understand how their road environment is evolving, where they should deploy their budget, what time they should intervene, and generally to give a safer and more resilient road network to the users of it.
This is where tires come in.
I was just going to come back to it because I appreciate I'm going off a little bit away from tires.
No, you're good. You're good. I know Pirelli is involved, so it has to.
Well, this is it. So I mean, I think this is where we about a couple of years ago we met some representatives from Pirelli Tires. It turns out that they have been developing something they call Cyber Tyre. This is a connected tyre. It includes sensors in the tyre substructure. And it enables the tyre not just to deliver traditional traction as it does to any vehicle. It also gives unique information about the contact patch, about the performance of the tyre that is useful in these different domains. And it turns out that Pirelli actually were approaching these two markets just like us, but using a tyre instead of a camera. So they were delivering automotive, but also looking to deliver data from their tires to road authorities for bumpy roads and where there was potholes occurring. And the premise was actually a tire plus a camera is better than just a tire or just a camera. Mm-hmm. And in the end, that was the logic behind us forming a collaboration that culminated in an investment by Pirelli into the Univrses of taking a 30% stake in the company and potentially acquiring the full company at some point in the future as well.
Yeah, they have the potential to buy the whole thing. Right. Yeah. So do you want to walk us through the 3 DAI in plain language so we kind of can understand a little bit more? I mean, I did my research, but honestly, it felt like I was reading stereo instructions a little bit there for a while.
So 3DAI is our core computer vision library that we've developed here at Univrses. I think the simplest way to think about it is it solves 3 problems for, let's use the example of a car driving through the world, trying to drive itself, to behave autonomously. And in order for that vehicle to drive itself, it needs to understand, first of all, its position, where it is relative to the world, so that it can, and indeed its orientation. So it's orientation. And so using a camera, we can infer the position of the car and its orientation of the car as it drives through the world. You might say, why not use GPS? Why not use other forms? Actually, the camera gives a very accurate trajectory. GPS is subject to noise. It can be interrupted. It's environmental impact. So it's not either or. We use both. So we have a GPS, but we also use the camera to give a very accurate trajectory. And GPS, of course, doesn't give orientation. It just gives your three-dimensional position. So with the camera, you actually get the pointing direction. So that's a key element of any autonomous system, whether it be a car or a moving platform, to be able to drive itself. The second element it needs of 3 is an awareness of the 3-dimensional structure of the environment in which it's moving. So I mentioned the first one is position, but now you also need to know where everything is in the world. Where are the other cars? Where are the sides of the road? Where are the trees? Where are the traffic signs? Where are the white lines? And using a camera, you can not only map where those features are, but you can actually place them in 3-dimensional space. So that the car is able to, using the camera and Univrses algorithms, build up this 3D picture of the world as it drives through it. And so you have its position and you have this 3D map of the world. And then the third element is where you actually bring in the AI layer on top. And so where you're actually looking at that 3D structure, that 3D map of the world, and putting an AI analysis of it and saying semantically, what is these elements of structure? This lump over here on the side of the road, is that another vehicle? Is that a park bench? Is it a traffic sign? And that matters to the vehicle because its response will depend on what that is. And so that is where we actually provide this third semantic layer on top, which says not only do I have the three-dimensional structure, so I know where to drive and where I can and cannot drive, I also know what that structure is made up of. So I have a better semantic understanding of the world. And based on these three elements of perception, I can then hand off to other elements of autonomy, things like path planning, control systems, which Univrses does not do, to be clear. So we do that perception piece, and that allows the car to behave more safely, more autonomously.
Yes, that makes way more sense than just reading it off of a computer screen. So thank you for that quick analysis. So you're collecting and interpreting a huge amount of visual data, it sounds like. So that,
Right.
in real time, is that
Absolutely.
a good way to, yeah. So
Correct.
what are the biggest technical challenges around something like that, having that much data?
Yeah, so I think one of the main challenges that Univrses is pretty unique to having solved is the challenge of calibration, which might sound like a kind of innocuous, low-level technical point, but actually it's the foundation on which all of these camera-based systems and indeed sensor systems are built. The latest vehicles that we work with have multi-camera systems now. So one of the leading brands in Sweden is deployed a flagship product that has 8 cameras on it. So all of those cameras pointing in different directions. And in order for the vehicle to understand the world, all of the different images from those different cameras have to be understood relative to each other, if that makes sense. And so when you detect a person in one image, you need to reference how that person sits with relative to the other cameras as well. And you have calibration rigs when you do the production lines, and all of the leading OEMs do. But the challenge is that calibration is only good at one point in time when the car rolls off the production line and the car lives in the real world. And these calibrations decay, they might get a bump, you might need to change the windscreen. And so what you need is dynamic calibration. You need online algorithms looking at the images all the time, saying, is the calibration drifting? Do we need to do something different? And the answer actually is what Univrses has developed for some of our customers is a multi-camera dynamic calibration system that says you do not need to invest in all this infrastructure to recalibrate all the time because we're doing it all the time online, in real time, in the car.
Yeah, so it's much like my truck. I have a fairly late model Ford pickup, but it's doing updates quite often. Is it something along those lines? So you'll be able to get that information that way?
So that sounds more like an over-the-air update where where the truck is saying to the server, have you got any new software for me? What I'm talking about is something that doesn't need any updates. It's simply running online behind the scenes all the time. Looking at all of the images all the time, saying, has something changed? If I'm able to look at these images all the time, I can detect if that calibration, if a camera has moved slightly because of a jolt or a bump.
A little bit, yeah.
Well, you mentioned, you're absolutely correct, because if you think about these vehicles now traveling up motorway speeds with obstacles perhaps coming into view at 100, 150 meters, so 300 or 400 feet, if you think your camera is pointing in a certain direction, it's off by only a fraction of a degree, the estimate of whether that obstacle is in the vehicle's path or not will differ. And of course, your response will differ accordingly. So actually, it's a very critical safety case to make sure that this calibration is correct so that the perception systems work and are accurate.
Yeah, no different. I mean, I deal with quite a bit blunter objects in my world, but no different than building a deck in your backyard. If you're at a quarter of an inch off, by the time you get to the end of the deck, you're a foot and a half off.
Exactly right. Yeah. Because of the angle, it sort of diverges. You've got it. Absolutely correct.
So if you don't mind, I'd like to circle back to the Pirelli partnership, right? So
Sure.
I did have a couple of questions. So in that deal, it's basically getting your computer vision into the Cyber Tyre platform. Does that
I mean,
sound
I think
accurate?
it's not a bad description. In the end, quite into whether collaborating with. I think in the end, what we're trying to do at a higher level conceptual. To a higher conceptual level is to integrate the sensor modalities from a tire and the sensor modality from a camera, and to recognize that actually, if you combine them, they are worth more than the sum of the parts. So if, for example, a connected tire is detecting, change it the other way around. If a camera is looking ahead of a vehicle and detecting particular surface conditions, a damaged road, some standing water, some leaves, the tire then can either confirm or otherwise what is happening, and that enables the tire to actually, the whole traction control system of the vehicle to be pre-triggered, if you like, so that it's prepared and deliver a better traction performance in the OEM space. But if we flip to road management, for example, one of the great things is we can actually confirm. So if you look ahead with a camera, you could detect surface conditions. The tire can then feel the surface conditions,
Confirm,
if you
like, right?
And confirm or otherwise to see. And this is really, you get to the nub of the core value of what we're trying to do, particularly for the DOTs and the road authorities, to deliver, yes, high frequency, so a lot of data coming a lot of the time, but critically, it needs to, of course, be accurate. They need to be able to trust it. They need to be able to say, if I see some information from Univrses and Pirelli, I'm going to deploy resources, I'm going to incur cost, I'm going to take time because I believe something is wrong and I need to fix it. And if it turns out, of course, that was erroneous, then that's all wasted and trust quickly evaporates. So it's absolutely critical to build that trust in the data we provide.
So I can imagine, as a founder of Univrses, and you had to have that connection. It had to make sense, right? You're not just going to take somebody's money, right? You wanted it to be, and you had to have that conceptually accurate. Like, it had to make sense. Like, I'm seeing it and the tire's confirming it. That to me makes sense. And you probably had to have that to be able to make this decision.
Absolutely. I think in the end, Pirelli they are not a venture capital company. They are not in the business of deploying their capital in multiple companies just in the way that a traditional VC does. What they are looking to do is say, where is the future of the tire business going? What is going to happen in the tire business in the next 5, 10, 20 years? And how can we position ourselves today to take advantage of that evolution of that business, of that industry? And I think what is clear by the investment they've made in the Cyber Tyre is that they believe that the tire is going to become much more than just simply a piece of rubber rotating on the end of an axle, delivering some kind of traction. Actually, by enabling the tire to deliver data and insights into what's happening, and then augmenting that with other sensing modalities like a camera, you're actually able to provide a lot more value to not just the automotive players, but other industries as well. And so I think that's the logic of how things are evolving for them.
And we're already seeing that in the tire world through pressure monitoring systems being embedded in the rubber, RFID tags being embedded in the rubber, things like that. So we're kind of seeing technology in tires, again, like you're saying, not just a hunk of rubber on the end of an axle. They're starting to see, the path and where that's headed. So I guess something else, are there any early, pilot program results, any kind of things that are happening right now that you can talk about?
Yeah, sure. I mean, I think particularly in that road management space, it's easier to talk about that one. I think some of the other there's a lot going on there, but I think it's better to focus on the road management for now. We've actually deployed late last year, at the end of 25 and into 26, down in the Puglia region of Italy, down in the south, right where the sort of ankle and heel of the Italian boot, if you like, if you look at the country on the map. And there we deployed with the road authorities, both the camera and the Cyber Tyre in conjunction, and we're able to give network scale to the entire network of hundreds of thousands of kilometers of road down in that region that hitherto was more or less unsurveyed, to give the politicians and the managers who are responsible for the budget a much better insight into their assets. to say, actually,
The
I
money.
now understand. Well, the road assets in particular. So of all the types of road, which roads are okay, which roads are beginning to fail, which roads are completely out. And the really interesting piece here is actually the roads that are completely out and in need of replacement, they already know about, and that'll be somewhere in the plan at some point in future. What they really care about is the roads that are beginning to decay. They really care about that because there is a huge value to them intervening early to say, I know something is going wrong here, but it's much cheaper, more efficient, and safer if I do a small thing now. I will buy more useful life of the road. That makes sense. Rather than allow it to decay to really bad and then have to replace it. So the cost of repairing the road is highly non-linear. So a little bit, and then suddenly it's very, very expensive. So if you can intervene early, it's a huge cost saving to the road authorities.
Yeah, and it all ties back to money, cost savings, really, taxpayer dollars, almost ultimately.
Absolutely.
So the prediction of the maintenance, what does that mean for safety? I can assume that would also help, the driver themselves.
Absolutely. I mean, I think in the end, if you have a damaged road, it's going to be less comfortable, of course, but it's also going to deliver less performance for the vehicle to be able to deliver the correct traction. And so I think the ability to intervene when there's an issue in a timely way, I think, is extremely valuable. I think this is, if you look at a lot of the contractors who deliver services to road authorities, they are all under very tight deadlines that if something is detected that is going to cause a safety case, they have to respond depending on the severity level, sometimes within the hour, sometimes within the day, sometimes within a few days, so to speak. So this is a great opportunity for them to become aware of the road environment that they are responsible for, to be able to be preemptive, be predictive, to say, actually, I can see that this is beginning to decay. Rather than allow it to become a safety case, I'm going to intervene early. I'm going to save some money, but I'm also going to provide a safer road environment.
Yeah. So I warned you, I'm a bit of a tire nerd, and I'm always going to tie it back, but I'm also a sustainability, circular economy. So I think there's definitely an emissions, like in a lower emissions, maybe effect that could happen here, a more efficient use of resources, obviously. How do you see AI-powered road intelligence kind of intersecting with the circular economy? Have you made those connections yet, or have you thought about that much?
In a more let's say theoretical way, we can do the kind of modeling and say, actually, exactly what you say, that if we can keep the rolling resistance of the road to be lower, then your emissions will be lower accordingly. You can look at how vehicles are routed depending on what the conditions of the particular road are to improve things. I think there's a huge potential for sure. I think trying to actually get the numbers on it, in terms of sustainability, it's a harder one to do because it takes time to build up the data to be able to validate it. But it's certainly something that's on our target list. If you think about what we're trying to save, it's time, it's money, it's lives, and in the environment. It's those four are our four priorities in what we're trying to do.
So thinking forward, what's next for Univrses after the Pirelli investment? Like, kind of, are they driving you, no pun intended, any particular direction, or is it still, you're running your game, they're running theirs, and you're trying to bring them together? Or?
Yeah, well, I mean, I think it's building out that bringing together of the two technologies, the two sensing modalities. We believe there's a lot of value in the automotive space, and now there is a lot going on with dialogues with several OEMs to say a camera plus a cyber tire can really bring a lot of value to, particularly given new regulation that's come to us. Maybe not so familiar, but in the EU, there is, where regulation seems to all come from, there is a lot of...
and you're in the other spot, California.
Yeah, exactly. But there's a lot of new regulation coming in around data for road safety. So where OEMs have to share data for road management, for safety management of roads around AEB, so automatic emergency braking systems. In order for cars to be sold in the European territories, they need to have functions like these and to get high Euro NCAP scores. And so there's a lot of opportunity, we think, for leveraging these two sensing modalities to try and deliver improved performance in these different areas. So that's what's going on in the automotive space. I can't say too much about it, but there's some really exciting dialogues going on. In the road management space, we now operate in 6 different countries in Europe. So Sweden, Norway, Denmark, UK, Italy. Netherlands and Italy, of course. Yeah. And so really looking to integrate cyber and build out the customer base, really grow that business. We've got a very strong foothold now. I think the other interesting angle here is how we bring in not just the data from the cyber tire, but also data from the wider OEMs. If you think about these OEMs, the Hondas, the Volvos, the Volkswagens of this world, they are all providing data that is consumed today by the car to help it drive itself, to help it drive more effectively and more efficiently. That data is now being shared through various pipelines, and companies like Univrses are able to scoop that data up, process it using in various AI and proprietary algorithms we've developed to yield insight that we think is valuable initially in the road environment, but also in other domains potentially as well. You have insurance, you have predictive maintenance. There's many possibilities, we think.
All right. So I guess now a couple questions on the personal side. What's been the most surprising through this journey? Was there something that you kind of thought would be one way and ended up being another?
So I think, I mean, if you mean by particularly the Pirelli collaboration, yeah, for sure. I mean, I think, Pirelli is this global 100-and-odd-year-old company that is now reaching out to this much smaller entity called Univrses, trying to leverage the technology. And there was a fear, I think, that perhaps they might use the scale and size to lean on us a little bit. Nothing could be further from the truth. They've been incredibly supportive of our journey, incredibly happy to learn from us, to take what we've developed and learned over the years and to try and use that information and expertise to enhance what they're doing. So I think that's been a hugely led to a very sort of virtuously circular environment, if you like, where the dialogue's been very positive, and we've developed some great relationships now with those guys. And I think there's some really exciting things to come for us.
So obviously, my listeners are typically tire recyclers. I deal a lot, with other types. I've had manufacturers on, I've had industrial tire producers on, and you're the first from this kind of AI data centered, kind of research and development. Sounds like you're really involved in research and development. Is there any way have you thought about maybe a way that our tire recyclers might benefit from some of this information? Is there any connection you think you could make based on?
It's a good question.
Because honestly, and I'm going to interrupt you, sorry, the components inside the tires, like I mentioned the RFID and I mentioned the pressure, that actually ends up being a workload for us on the end of
Interesting.
life. So I don't know if these conversations are happening on the front side of things, where the OEMs and those are having a conversation. Well, they're going to have to grind these tires up someday. Maybe we should really be aware of what we put inside the tire. Is there any of those conversations having? Have you wrapped your head around that at all? And
so I'll be very transparent with you. We have not. I'm as I mentioned at the top of the interview. I'm fairly new to the tire industry. I'm really learning a lot about the latest technology for taking tires and using them in road surface development, for example, these rubberized tarmac applications, which I think is fantastic. And so I think there are possibilities where we can use our computer vision perhaps to analyze those roads and analyze how they are performing as well, once they become deployed more at scale. In terms of the post-processing, let's call it, or the afterlife processing of the cyber tire and the connected tire, I know that the sort of circularity, if you like, of the tire life is a huge priority at Pirelli. We've spoken to them a lot about that overall concept. Quite how they're approaching it with that particular part of it, I don't know the answer to that, but I can assure you that it will be very much front and center of their mind, because it's, as I say, it's a core principle for them to build this circularity into their tires.
Perfect. And you did it. That is a great connection. I hadn't gotten there yet. So we are actually, rubber modified asphalt is a big push for us right now. We're meeting with different contractors and folks that are basically, we haven't experienced that in the West near as much as on the east side of the United States. And there are tens of thousands of miles. And a big part of that is longevity of the roads, rutting, cracking. All of that would be amazing data to have in real time, like you're talking about. So there's definitely something there, and there might be, something to keep that in mind when you're processing some of this information.
I mean, I think if for our experience of the road management industry is that it tends to be quite traditional. It doesn't move that quickly. They tend to do what they've always done. And in the end, if you're bringing along a new material made from recycled tires to resurface the road, you will need to prove unequivocally that it improves things in a way that's quite substantial for them to move away from what they've already been doing. That's not always the case. There are many more. There are many road authorities who are prepared to try things, but that's in general our experience. So, taking that as a sort of the starting point, I think there is a great opportunity here to say, where are there been roads developed from recycled tires? Where are the more traditional roads, and how can we analyze how they perform given the different conditions, given the different duty cycles, not just using spot checks with the eyeball, not just using annual surveys and extrapolating, interpolating in between, but using this kind of network scale intelligence that we can now deliver using Univrses cameras and Pirelli tires to give a better insight as to how these different types of materials are performing in the road environment, and where the deltas are, where the gains are, where the benefits are. Because I think that's our experience. If these things are to take off and to be integrated into the workflows and used in the everyday processes of these road authorities, they need to see the data, they need to see the benefit, they need to understand, and to your point, the money. How is this going to benefit us over that?
We did it. That's the connection. I was wondering, in starting this podcast and even researching where this would connect, I really feel like that's a good spot. And I will have listeners on here from Liberty Tire, from other tire recyclers across the world. Actually, I've seen some logins and comments from all over the world. So, maybe we found something. Maybe we've dug into something that could be, applicable later. So to be continued in the world. So, what did I miss, Jonathan? Anything that you're excited about that you wanted to make sure you talked about today? I know digital security was a big part of things that you guys are taking serious over there.
Yeah, it's just something we always get asked, and I just wanted to let your listeners know. In the end, we are putting cameras into the public environment. The reason we do that is because we want to harvest information about the road environment to help the cars drive themselves, to help the roads be managed in a better way. We do sometimes collect pictures of people. We do see license plates of other vehicles, for example, personal data. I just wanted to let everyone know that we are very careful how we process that. We do not let those images leave the vehicle unless they are anonymized. And so there is an anonymization process that takes place. Actually, it's the first thing that happens in the cloud, if I correct myself. But we remove the license plates, we blur them out, we remove the faces, we blur them out, we delete and throw away that original image, and all that makes it through to our customers and our clients is the anonymized image. It's the same thing with the tire data as well. We're very careful about how we manage that. And I just wanted to highlight it because it's something we always get asked.
Well, I mean, in all honesty, I could see it becoming where you have an accident on video, where you have, there could be some legal ramifications, and you could have other authorities, maybe not road authorities, but other authorities asking you, hey, do you have an image of this particular thing that happened or that? So it's good to hear that you guys take that very seriously.
Yeah, absolutely. And I mean, just to your point, I think there are other authorities who have inquired. I think it's less about the sort of post processing of an accident or something like that, but there are examples where you've put the cameras to detect certain things. You have some imagery, but then people come back to you and say, "Oh, by the way, can you detect this thing as well?" And of course, the answer is with using the latest AI technologies is yes, we can. And it's a really nice value to say, just because you've driven once doesn't mean you and detected certain things, doesn't mean you can't detect other things even after the event, even after you've done the drive.
Well, Jonathan, I really appreciate you coming on. I've learned a lot. I'm sure my listeners will learn a lot, and it may spark quite a bit more conversations. You might see some comments out in the world, or maybe an email here or there, hopefully about Talkin Tires, our podcast we're pretty proud of here. So thank you for coming on, and good luck to you and all your ventures, and we appreciate you.
No, Craig, look, it was super to be here. I'm very grateful for you to giving me the time to talk to and Talking Tires. It sounds like a great podcast. I've listened to a couple of episodes, as I said, preparing for this, and it's super interesting. So I'm very happy to be here. And yeah.
All right. Thank you.
Good. Bye-bye.